Hello guys, welcome back to my channel, Mason African Motives. Still working on the question paper which was written in July 2019 for mathematics N3. So remember we managed to work on the first part and the other questions, and working up to question number 4, where we had that question 4 which was actually not clear, and so we shall just quickly rush to question 5. That's what we have. So on question number 5, we are given function f defined by, so that's our function f and g. Determine algebraically the coordinates of the point of intersection of functions f and g. Okay, so we need to find the point of intersection, that is the points of intersection. Remember guys, when we are working with the points of intersection, that you are supposed to solve the given equations simultaneously. So you have to solve simultaneously the given equations. All right, so we have got the first equation. We are going to take this as our first equation of y is equal to x minus 1, so that is going to be our first equation. Then another one, it's x is equal to 2y squared. X is equivalent to 2y squared, like that. So that's going to be our equation 2. So remember, I want to solve this is by calculation. They are just saying by calculation. We could have used by graph, but they are saying by calculation. That is what they mean. So from equation 1 already here, y is the subject, so I can choose to substitute it here, or I can just choose to substitute x into equation 1. Just whatever that you feel like, guys, it's best for you. I don't know what is going to be best for you. All right, so you can choose anyway. So if you choose to substitute here, it's going to be equation 1 into 2. So you're going to substitute equation 1 into equation 2. So like I said, guys, you choose which one is best for you. So this is going to be x is equal to 2 into y, which is x minus 1. So we are going to have x minus 1 squared. So the only disadvantage here that we're supposed to expand now, where we have got x minus 1 into x minus 1, where we are going to have x squared, x and minus 1, which is minus x, minus 1 and x, which is minus x, minus 1 and minus 1, that's going to be plus 1. So you're going to have x squared. This is minus 1 minus 1, which is minus 2x plus 1. So you're going to have x is equivalent to 2 into x squared minus 2x plus 1, the one that you obtained here. So you can multiply by 2. That's going to be 2x squared minus 4x. Okay, this is going to be minus 4x plus 2. And just solving this, we are going to have 2x squared. All right, that's 2x squared minus 4x. So if we take this x to this side, it's going to be minus x plus 2 is equal to 0, like that. So this can be written as 2x squared. So we've got minus 5x plus 2 there. Minus 5x plus 2 equal to 0. So that's our quadratic equation. So either way, even if we are going to work with y, we are going to have an equation with 2y squared. So the factorization part is the one that you're going to use, or you can use quadratic formula. I don't know which one is best for you, but using factorization, remember the coefficient of x squared here is not 1. So we are going to do the longer way, where we multiply the first term and the last term. That's going to be 2 times 2, which is 4x squared. So what are the terms that we are going to multiply to give us minus 4x squared? But if we add them, they must give us the middle term, which is minus 5x. So definitely we've got minus 4x and minus x there. These are the two terms that we can actually work with. So that's 2x squared minus 4x minus x. We substitute into the middle term, then we've got plus 2 is equal to 0, like that. So this is by grouping. We are going to group our terms into 2 terms like this. We factor out what is common here, which is between these two. We are going to have 2x into 2x squared divided by 2x, which is x, minus 4x divided by 2x, which is minus 2. So what we need is to make sure that this part and this bracket should be the same. This is minus x plus 2, but this is plus x. So you are supposed to factor out a negative so that this will be a plus. So negative and negative, that's a plus, plus and minus, that's minus 2, like this, which is equal to 0. Because if these two brackets are the same like this, we can factor out that common bracket. Then you'll be left with 2x and minus 1 on the other part, which is equal to 0. That's it. So our x is going to be 2, or from this bracket 2x minus 1 is equal to 0. So 2x is equal to 1 divided by 2 by 2. So x is going to be 1 over 2. So these are the possible values of x that you're obtaining: a positive 2 and a positive half. And remember, what we need is the point of intersection, which is the points of intersection. So we're going to substitute these values now into any one of these equations. We can substitute, since we've got the value of x, want to find the value of y, we can take advantage of this equation where y is already subject. So using this equation, y is equal to x minus 1. Our x is 2, so when x is 2, y is going to be 2 minus 1, which is 1. So y is going to be 1 here. Y is going to be, when x is a half, you substitute a half, that's going to be half minus 1, which is minus half. So these are the possible values that we are having. So therefore, as a point, we are going to take the value of x and y, which is 2, and y is 1 at that point. So it's 2 and 1. And another point, when x is a half, our y is a minus half. So when x is a half, our y is a minus half, like this. So therefore, these are the 2 points of intersection that we are having, or that we are going to obtain from that question. So that's what we had. Let's see another question, which is to draw the graphs of the functions to show the solution obtained on 5, as well as the turning point and the intercepts with axis. All right, so in order for us to draw, definitely these graphs, they are going to intersect at a certain point. So I'm just going to have it as a sketch, but you actually understand what is happening, because what you just need is something like this, a Cartesian plane. Make sure that you've got straight lines there. All right, that's your x and that's your y there. All right, so let's start with y is equal to x minus 1. This is a straight line where you can just draw direct when in the, because we know that in the x-axis y is equal to 0. So you can just ask yourself that when y is equal to 0 there, what is the value of x? Okay, so we're going to have 0 is equal to x minus 1 to this side, so x is equal to 1. So which means x is 1, which means it's going to pass through the point 1 in the x-axis, and in the y-axis we know that x is equal to 0. So when x is equal to 0, y is equal to 0 minus 1, y is equal to minus 1. So which means our y-intercept is at minus 1. So if you're using a graph book, you mark point 1 and point minus 1, you join your points. That's gonna give you a straight line there from your graph book. Okay, so here I'm just gonna use a plain paper like that. So but that is the presentation that you're going to have, passing at 1 and minus 1. So this is your y is equal to x plus 1. No, it was x minus 1, sorry. So that's what we have for the straight line, and we have got this here, which is x is equal to 2y squared. X is equal to 2y squared. So actually, this type of a function, you're going to see that for the values of x that you're going to have, because if we make y to be the subject here, you're going to have it like this. I want you to see what is going to happen. It is going to be, because it was x is equal to 2y squared. If we make y to be the subject, we're going to divide like this, which is y squared is equal to x over 2. Then you have got square root like that. So which means y is going to be plus or minus the square root of x over 2. which means like when x is 0, we've got plus or minus, which means we're going to have like one value here, two values. Okay, we move on. Maybe when x is equal to 2, yeah, let's just move on to 2. When x is equal to 2 like this, we are going to have it as 2 over 2 like this, which is the square root of 2 over 2, which is going to give you 1, but it's plus or minus 1. So there are two possible values when x is equal to 2. Maybe this is our 2 here. We've got two possible values, a plus 1 here, a plus 1. A plus 1 is going to be actually on the line, and a minus 1 here somewhere like that. You move on to maybe 4 and so forth. So this is what is going to happen. So your curve is just going to be like this. So this corresponds with 1 and this corresponds with minus 1. So it's supposed to be somewhere here, guys. Remember, our minus 1 is here, so it must correspond somewhere here like this. All right, so your curve is going to be, remember we have got a point here at 0 here, so it's going to be like a curve like this. It's now too much, guys. It's now too much. It's supposed to be like this. All right, and then another part joining the 2 and the 1 here, so maybe somewhere here, yeah, something like this, 2 and the 1 here. So this is 2 versus a 1. Which one? This one corresponds with 1, and this one is 2 corresponding with minus 1. So as you can see, these two graphs, they are intersecting at 2 points, this point and this point, which are those points that you calculated on the first question. Remember, your first question was to calculate the point of intersection there, where we have got 2 and 1, half and minus half. So which means this is definitely, because this is 0 and 1, so this is your half and minus half here, and this is your 2 and 1. As you can see from that part, this is your 2 and 1 and something like that. So that is what we had. So the question actually wanted us to indicate this, as well as applicable turning point and intercepts with the axis. So these ones, the axis here for the straight line, and for this one of x is equal to 2y squared, it is going to pass through the, that is where it is going to pass through this point only, just like that. So that is what you had, and you've got 7 marks for that. All right, then on 5.2, determine divide x of the following function by using the rules of differentiation. Leave the answers with positive indices, take note, and in set form where applicable. Where applicable, leave it in set form and as positive exponents. All right, so let's just try and see what were we supposed to do to find divide x here on 5.2. So remember, y is equivalent, that's 3, and this is the cube root of, so it's like this, the cube root of x squared like this. All right, plus 5 over the square root of x. So before you do any derivative, before you find any divide x, first make sure that you rearrange in a format that you understand well, which means you have to apply your laws of exponents. Remember, from your laws of exponents, x to the exponent of m over n gives us the nth root of x to the exponent of m. So this is m over n, and your n is the one that is inside the root, this one. So which means we can rewrite this as 3. This 3 is going to multiply whatever that you're going to have here, which is x to the exponent of the n, which was in the root, is the denominator. So this 3 is the denominator, this one. So it's x to the exponent of 2 over 3 like this. That is what it means. All right, plus we have got 5 over the square root of x. From our laws of exponents, we know that x square root of x is x to the exponent of a half, but it's over now. So for us to write it on top, is going to be x to the exponent of negative half, like that, from your laws of x, because it's 5 over. All right, then at this stage I can now determine my divide x. Remember, divide x, you drop the exponent, you multiply this to the exponent, so it's 3 times 2 over 3, then you subtract 1 on the exponent here, so it's 2 over 3 minus 1, which is minus 1 over 3. Okay, plus 5 multiplied by, you drop the exponent, this one, negative 1 over 2, it multiplies to 5, x to the exponent, you subtract 1 there, so it's going to be negative 3 over 2. All right, so that means our divide x is going to be this 3 times 2 over 3 is going to give us 2, x to the exponent of minus a third. 5 times minus half is going to be minus 5 over 2, x to the exponent of minus 3 over 2. But remember, the instruction was saying leave your answer in terms of positive exponents and in said form where applicable. So we have to introduce positive indices there, which is exponents. So here we have got to the exponent of minus a third. So to bring out a positive is going to be 1 over. And take note, what is carrying a negative is this part here, not 2. So it's going to be 2 over x to the exponent of a third. Minus, here it's x which is carrying again, so it's going to be 5 over 2x to the exponent of 3 over 2, like this. The 2 is already in the denominator, this one. All right, so we have got positive exponents, but we know that from our laws of sets, laws of indices, we can actually introduce the sets here. So this is going to be like this. The cube root, because it's to the exponent of a third, and we know that to the exponent of a third means the cube root of x. So it's going to be 2 over the cube root of x, like this. Then we have got the same thing here. I want you to take note, this one here, we took it and we rewrote here to here from this concept, but this time is 3 over 2. So it is going to give us minus 5, which is on top. Then this 2 over 2. Then we simplify this alone, this one, which is applying this law. This is going to be square root of x to the exponent of 3. There's a 2 here, but this 2 you cannot write it. So it's going to be square root of x to the exponent of 3 from your laws of exponents there. So that is what you're going to have. So as you can see, your answer is now having positive numbers in terms of exponents and sets. Wherever it was applicable, we managed to do that. So that's how they can ask these questions, guys. You have to be very, very careful. Then let's see the other question that we also had here. All right, let's see this question. So on 5.3, we are now given the diagram in fig 2 shows that is our f of x. T is the x coordinate, that is x coordinate 2 there, the point T. They are saying the value of x here is 2. Find the gradient of the tangent to the curve at T. Okay, so the question is asking us to calculate the gradient of the tangent. If we have got a tangent here at T, what is going to be the gradient of that tangent? Okay, so remember, guys, the gradient simply means divide x. In order for you to have the gradient, you must find divide x, which is actually equal to the first derivative, that is your divide x at given point, at the given point. So the given point, that is the value of x at the given point, which is our x is 2 at the point T. So we have to find f prime of this. Remember, our f of x, guys, is given as negative x cubed plus 6x squared minus 9x, like this. So we are going to find f prime, which is the first derivative with respect to x, and this is gonna be minus 3x squared. Sorry, remember we drop the exponent, this one, it multiplies, it's minus 3x squared. we do the same. We drop the exponent, then we subtract. So it's going to be plus 12x minus 9. Remember, when it's a 9x, you just take the constant, which is minus 9. So at the given point, the value of x here is 2 at the point t. Remember, at point t, the value of x there is 2. So you're going to substitute 2 now to find the gradient. So the gradient now is f prime of 2, which is minus 3 into 2 squared plus 12 into 2 minus 9. So in place of x, we are going to substitute on the first derivative, which is going to be our gradient, and this is going to give us 3. So the gradient at this point is 3. That is our gradient. All right, so that was it, guys, on this question to obtain 19 marks. All right, then we move on to question 6. We are given calculate the values of x that will satisfy the equation for, these are the values of theta if tan. All right, we are given such a statement on 6.1 that tan x minus 30 degrees is actually equivalent to 1 over square root of 3, and we need the values of x that are going to satisfy this interval. So the first thing to note is that this tan that you're talking about here, which is equivalent to this, it's a positive that we are talking about. It's a positive value because this is a positive. So we need to find, from all students take calculus, the quadrant where tan is a positive, which is the first and the third quadrant. That is where we are going to have our answers. So we are going to find, in this case, the reference angle from this tan. We are going to find the reference angle. So we are going to have x minus 30 degrees, which is equal to arctan, since we want to find the angle. So it's going to be arctan this part, which is 1 over square root of 3, like this. So this is going to give us the reference angle, the one that we are going to use to locate the quadrants. Okay, so we have got x minus 30 degrees equal to arctan 1 over 3. And this arctan is just shift tan from your calculator, shift tan, okay, which is going to give you 30 degrees. So this 30, we must first contain this to see if it is the actual angle. Okay, so remember, in the first quadrant you take the reference angle as it is, so that is the one. So this one is true. We move on to the third quadrant, which is an angle is going to be here, so it's going to be 180 plus the reference angle. Remember that. So it's going to be 180 plus the reference angle, which is 30 degrees, of which 180 plus 30 is going to give us 210. So this is going to be 210 degrees. Therefore, we are going to have two solutions, because tan is positive in the first and in the third quadrant. So we shall have another equation starting with x minus 30 degrees and equate it to the arctan of the angle, which is equivalent to 30 degrees, and that angle is 210 degrees in the quadrant of tan, this one. So these are the two values that we can have. So let's solve for x. We can transpose x is equal to minus 30 to this side, which is going to be plus 30 degrees. So 30 plus 30, which is 60 degrees, or another x is going to be minus 30 to this side. We transpose, is going to be plus 30 degrees, which is 210 plus 30, which is going to give us 240 degrees. So these are the possible values of x that we can obtain in that interval of 0 to 360 degrees. So you are supposed you are supposed to understand your quadrants, guys. How do you work out your quadrant, something like that? Okay, then on 6.2 we have a question to prove the following trigonometric identities. So that one is supposed to be trigonometric identities. There we need to prove that these two, they are equal. All right, this is cos 360 minus a, and we know that this lies in the fourth quadrant. We all know that this lies in the fourth quadrant, and in the fourth quadrant cos is positive, so this is actually the same as cos a. Yeah, this one is same as cos a. Okay, anyways, let's work out the right hand side. On the right hand side we are given, so I'm going to work with the right hand side here. We are given that 1 minus sine squared into 180 degrees plus a. This is what we have, everything over 1 minus cos 180 degrees plus a, like this. This is what we have. All right, remember we are actually working with the quadrants. That is the best way of answering this question. Sine 180 plus a, which quadrant is this? That 180, where we have got 180 plus a. This is actually third quadrant, where we've got 180 plus a, because a is reference angle like this. So, and we've got all students take calculus. This quadrant is for tan, it is not for sine, which means our sine is going to be a negative. It's going to be minus sine a, like this, because this quadrant is not for sine, it's for tan. So it's going to be a negative. All right, so this is what you're going to have. We are going to have is that 1 minus our sine, this one, which is a negative but being squared. So it's going to be minus sine a, like this. Then we have to square it. Everything over this part here is going to be over 1 minus, we have got cos 180 plus a, okay, and we said 180 plus a. This is the same quadrant, 180 plus a, and this quadrant is for tan, it's not for cos, which means our cos is going to be also a negative. So it's going to be minus cos a, because this quadrant is for tan. So it is going to be minus cos a, like this. So it's minus minus now. All right. Therefore, let's see what we are going to have at the end. Let's see. This is going to be 1, right, minus, we have got a negative here, so this is minus sine, and this is squared, as you can see. So it's going to be sine squared a over minus and minus, which is a plus, so it's going to be 1 plus cos a, like this. This is a minus and a minus, so it's going to be 1 plus cos a, like this. All right, now that we are at this stage, we have to try to simplify further in a way that we actually understand our identity. So it's now a matter of identities here, and from these Pythagorean identities, we have got cos squared a plus sine squared a, which is equivalent to 1. And here we've got sine squared a, so we can at least make this to be the subject, which means we can transpose this to the other side of the equation, which means sine squared a is going to be 1 minus cos squared a. So that is what we have in place of sine squared. So this can be written as 1 minus cos squared a over 1 plus cos a. So at least we have got something that has to do with cos here, but how is it going to help us? All right, remember 1 minus cos squared is actually a difference of two squares, this one, because it's same as 1 squared minus cos a squared. This one is not the same, it's not different from 1 minus like that. So remember, from your difference of two squares, x squared minus y squared, it gives you x plus y into x plus y. You simply take these terms which are being squared. So you've got 1 and cos a. So it's going to be 1 plus cos a into 1 minus cos a, like this. All right, so that's what you're going to have from this part here. Okay, so remember what we wrote there. So it's going to be 1 minus, we said we are going to have 1 plus cos A into 1 minus cos A, like this. Everything over this part, which is 1 plus cos A. So it's going to be 1 plus cos A, like this. So which is somewhere there, guys. We are almost there. Cancel these two because they are the same. So we are going to be left with 1 minus, take note, this is a bracket of 1 minus cos A. So we have to expand this bracket and simplify further. That's 1 minus 1 times 1 is minus 1, minus times minus, which is a plus cos A. So we have got 1 minus 1, which is a 0, plus cos A, which is cos A. So this is our right hand side, guys, which is cos A. And remember, when we simplified our left hand side, we said this is going to give us cos A. Cos 360 minus A is same as cos A. So this is actually equivalent to the left hand side. So guys, as we can see, that is what we needed there. That is what we needed to prove and work out these. So in order for you to prove identities, it's not like something that is direct. But what you do is you work with the question that you are actually given. It's not like something which is direct. You work with the question that you are given. You relate identities, combine identities so that they can give you something which is direct, something like that. So it's not something that is direct. And the best way is to actually revise along the lines, work on many identities and so forth and so forth. So that's what you can actually do. So the other question that we are given here is that in Fig 3 we are given a land surveyor wants to determine the height of a tower AB. So this is the tower AB. So he wants to determine the height of this tower. All right, when he finds out that from a certain position C, this is the position C, which is the same horizontal as B, an angle of elevation of the top of the tower is 56, and from another position D, 20 meters away from C, which is between B and C, an angle of elevation of the top of the tower is 74 degrees, which is this one at D, and we can see there is 20 meters in between. Now calculate or determine AB, which is the height of the tower, this one, from A to B, guys. This is what we want to determine, which is the height of the tower. What can we do? What are the stages that we can take? Actually, you have to at least try and figure out what is best to answer the question, because what we just have is this distance from B to C, this one, from D to C, this one. All right. So maybe if I can choose maybe to calculate AC, then I can be able to calculate AB. Or I can choose to calculate AD. That means I'll be able to calculate AB again, if I can choose to calculate AD. So it depends, guys, with what you want to calculate first. All right. So as for me, I'm going to calculate AD. That means I need to find this angle inside the triangle, which is angles on a straight line. So it's 180 minus 74, which is 106. So I'm going to have 106 degrees here. Then I'm going to find this angle A here, which we know that angles in a triangle add up to 180. So to find angle A, I'm going to subtract those two angles from 180. So angle A is going to be 180 minus the sum. Sorry. So it's 180 minus the sum of the given angles in this case that we have. And which are these angles? That is 106 and 56. So we have got 106 degrees plus 56 degrees, like this, and this is gonna give us something like 18 degrees. So this is going to be 18 degrees. So here we shall have 18 degrees here. All right, so remember what I said, guys. I'm going to calculate AD. As for me, I'm going to calculate AD. All right, so calculating AD, this is the triangle that I'm using here. I'm having like a triangle, like it's a non-right angle triangle that is actually there. So which means we can apply sine rule, because here we have got an angle which corresponds with this side, and we've got this angle, and we want to calculate this side here, so it's opposite to each other. So you can apply sine rule. Remember, sine rule, it's when the side and the angle corresponds to each other. So we know that our sine rule states that A over sine A is equal to B over sine B. So A over sine A is equal to B over sine B. So which means our A is the one that we want to calculate, which is this A to D. All right. So you've got AD over sine of the angle. So it's AD, this one, over sine the angle which corresponds, which is 56. So it's over sine 56 degrees, which is equal to B over sine B. So the B is the one that we are given. This one, we can use this 20 over the sine of the angle, which is 18. So it's 20 over sine 18. So there you can play around. As you can see, want to remove this sine, so you can just remove by multiplying by sine 56 degrees here, by multiplying by sine 56 degrees here. This can cancel, guys, which means AD is the subject now. So AD is going to be 20. This is same as over 1, so it's 20 times sine 56, which is 20 sine 56 over sine 18 times 1, which is just sine 18. So make sure that your calculator is in degrees there. Make sure that your calculator is in degrees. Simplify this, you are going to obtain 53,65643, something like that, which is, you can measure to 3 decimal places, which is going to be 53,656. That's 656 in meters. Okay, these dimensions are in meters. So remember, the reason of calculating AD, this is our AD, this one, but we want to calculate this side. So I'm going to use triangle ABD. Okay, so I'm going to use triangle ABD. So use triangle ABD. So it's like this. This is my triangle ABD, this one. All right, this one. From A to B to D. Remember, we want to calculate this height, which is AB. So we have got our A to B and to D here, and we calculated AD. Remember, we calculated AD and we obtained this 53, whatever that we have there, 53,656 meters. And we have got this angle here inside D. The angle is there, which is 74. This one, the angle is there, which is 74. So you've got 74 degrees here, and you want to calculate AB, and this is 90 degrees, this one at B, and this is H, which is your height, which is there, B, this one. So definitely I can apply trig ratios, because this is a right angle triangle now, so I can apply trig ratios. Remember your soccer tour. Remember your soccer tour, guys. According to this 74 degrees, this is your opposite, and this is your hypotenuse. According to 90 degrees, this is your hypotenuse. So which ratio uses opposite and hypotenuse at the same time? It's only one ratio, and this is the ratio for sine. There is only one ratio with opposite and hypotenuse, which states that sine theta is opposite over hypotenuse, which is sine theta 74 degrees is the opposite to 74, and the opposite is AB. So that's AB over the hypotenuse, which is 53,656. So therefore I can calculate AB, which is the question that I was asked to calculate. So 1 times AB cross multiply, it's going to be AB is equal to 53, times this one is going to be 53,656 sine 74 degrees, like that. So that means our AB can be determined now from our calculator in degrees, which is going to be 51,577 457 6, something like that. So you can actually round off this AB to 3 decimal places, which is 1, 2, 3. So that's 51,577, because this 4 cannot change this. So that will be our AB in meters. So therefore our AB is 51,577 meters. So guys, as you can see, there was a lot that we had to go through, but that's how they ask these questions actually. Then on question 6.4, we are given a fig 4 which shows the graphs of f of x and gx, okay, and the interval from 0 to 180, from 0 here to 180 degrees. And the question is determine the values of a, b, and c. So as you can see, your a, your b, and c. Okay, so remember, a is the this is amplitude, this is a is the amplitude, okay, which is the maximum value that we have on this graph. So okay, let's just write this 6.41. So our a is going to be the amplitude of what, of f here, because from the graph of f, this one. Okay, so the amplitude on f, the maximum value, as you can see, the minimum value is at -2, the maximum value is at +2. So that is your amplitude, the maximum value there. So a is 2. All right, then b, where can we obtain our b from? B is here on sine x, this one. So this b, you take it from the period of the given graph, okay, the period of the graph. So as we can see that from this graph is sine x, this one, 0 versus -1, and 90 versus 0. And so this is actually this is from minus, I want you to see what is happening from -1 here up to -1. This is half of a cycle, so which means it is going to complete another cycle. If it was to be drawn up to 360, it is going to complete a cycle. So which means this b is going to be a 1, because we find this b by saying the new period divide by the old period. All right, that's gonna be old over new, sorry, that's gonna be opposite there. So the old period is 360 and the new period is 360 there. So dividing these two is going to give us a 1. So that's our b. All right, then c, as you can see, c, it's a shift which happened. We know that from the actual graph of sine, it was supposed to start here at 1. It was going to be at 1. It was supposed to be like this. That's 0. That's 0. It was supposed to be here, guys. Sorry, the graph of sine starts at 0 like this. So it was supposed to be at 0 here, then 90 at 1 like this, then 180. It goes back to 0 like that. So that is what it was supposed to do, like this. So as we can see, it was supposed to be like this, but now instead of starting at 0 here, it's now starting at -1. So as you can see, it shifted downwards -1 unit. Every point is shifting downwards 1 unit. So that is your c. So our c is a shift of a -1. It shifted downwards 1 unit. So c is -1. So that's what we are going to have there for these values. And the question is, read from the graphs the values of x where, take note, a cos bx. Okay, let's just write in terms of a cos x, which is, this is your a cos x, this one, which is f of x. So they are trying to say f of x like this, minus sine bx, but we do not have sine bx. We have got sine bx plus c. So what are we going to do? I want you to see something here. If you transpose this minus sine bx to the other side of the equation like this, it is going to be written as sine bx plus c like this. If you transpose this negative, it is going to be positive sine bx like this, then plus c. And we know that this sine bx plus c is equivalent to gx. Sine bx plus c is your gx. So we want the values of x where f of x is equal to gx, because this is same as a cos x is equal to, you transpose that to the other side, is going to be sine bx plus c like this. So this is f of x is equal to gx. That is the point of intersection. that is the point of intersection of the two graphs. That is where they are equal. So these graphs, if you are to cross check these graphs here, they go like this. Okay, they intersected at this point here at 90 degrees. That is where the two graphs are intersecting. So it's the point of intersection of the two graphs, because we are saying these two, they are equal, and if these two are equal, it only happens at the point of intersection. That is the idea there. So please take note how you answer the question, because these guys, they always try to confuse you. You see the arrangement that they did here, it was supposed to be like this, but they just try to manipulate whatever that you be given in a way that you will be confused when you're answering these questions. But there's nothing there much, there's nothing. All that you need is to work on question papers and revisions. That's what you're gonna have, so that you can have a total of 100 marks, just like that. So that's what we had, guys, from this question paper that we were working on. So more questions and question papers to come, so not to miss these classes and these question papers that we shall be working on. Make sure that you subscribe to the channel Mason African Motives and turn on your notifications so that you won't miss these classes for Mason African Motives. Till we meet again.